Let's have a look at that Hess's Law Lab, and there's not too much to it, so I'll give you a little bit of an intro, and then I'll just let you go ahead and give the calculations a try, okay? So for the first thing is just on the note, just has a look again at what calorimetry is and how you do that. So if I've got a coffee cup here, for example, the ones in the lab are actually just a regular old styrofoam coffee cup, and we'd fill it up with a little bit of water, add a little bit of solid sodium hydroxide, dissolve it. Once you've got the lid on there and pretend that this was like a little thermometer, you can just measure the temperature change of this solution as it's dissolving. And then what we're doing is with Hess's law and the concept of calorimetry is that we can capture the amount of energy that's released when the sodium hydroxide dissolves. Because we know the volume of the water and the specific heat capacity of water and the temperature change, we can calculate the enthalpy. We're going to have 3 different reactions, collect the data, or the fake data in this case because it's a dry lab, and then we're going to see if Hess's law works out by if you add up reaction number 1 to reaction number 3, algebraically, do you get reaction number 2? Okay, and that's basically Hess's law by adding it up and to see if this data actually supports that. So you can read through the instructions if you haven't already, and then I'm going to just scoot to the observations table. And then I did the first one for you. So I did the first one, you do the reaction number 2 and reaction number 3, but I'll just talk you through it. So if we had 1.99 grams of sodium hydroxide, and then we have our initial temperature of the water and our final temperature of the water, you can see that the temperature went up. So clearly that's going to be an exothermic reaction because heat's going to be produced. What's the total mass of the solution in my calorimeter? Well, it's going to be 102 grams because you want to get the mass of the water plus the mass of the sodium hydroxide that's in here. So your total mass of the solution is what you're looking for each of these reactions, okay? Once you've got that, and you can see we just used the density of water to be able to calculate what its mass was. And we're also going to just assume that the mass is going to be, the density of our solution with sodium hydroxide and water is going to be pretty much identical to what it would be with just water. Okay, so take that into account. Once you've got this calculation done, flip to the data table where you're going to record all of your information. So in question number 1, or so the first part of the table right here, you're simply calculating your enthalpy for that reaction. Just make it a little bit bigger here for you. Okay, and you're going to record that value in joules to 4 significant digits. Once you've got that value, then we're going to be able to calculate the number of moles of sodium hydroxide that we used using the molar mass. Once we've got the number of moles, then we can make an expression that relates to how much energy per mole. So simply dividing the first box by the second box will give you a number in joules. And then let's just convert it to kilojoules because it makes a bit more sense just because the number is fairly large. So there we go. So reaction number 1, the enthalpy per mole is going to be negative 43 kilojoules per mole. That's referring to our exothermic reaction for the enthalpy. And what we're going to do is then you go back, fill in the rest of the table, go back to the questions, and I'll just show you which questions I'd like you to work on. Okay, so here we go. Question number 1 was simply doing our equation, so the balance, the ionic, and the net ionic equation, and you can simply check my solution. They're on the next page in the handwritten purple letters. Question number 2 and question number 3 are just great practice questions. How do you make up a solution again, and how do you practice some stoichiometry? Question number 4 and 5 are super easy. They're just looking at some equations and just using the enthalpy, write it as a thermochemical equation, or vice versa, take your thermochemical equation and express it using the negative or positive delta H value. Question number 6 is where you actually take the data from the lab and you're going to compare it. So here's where you're going to see, does reaction number 1 and 3 add to give you reaction number 2? It lets you calculate the percent difference, and you can think about, like in the lab, why might you not actually get the actual answer of reaction number 2? Why are they a little bit different? And that can just be explained using experimental error. Okay, so you don't really have to do question number F if you understand the equation. I wouldn't bother about doing G or question number 7 either. But question number 8 might be a nice little round finishing up type question, where if you are given a couple of equations and you want to associate the heat with the condensation of water in the gaseous form to liquid droplets, just how do you rearrange those equations and solve. Okay, and that's it for the dry lab for enthalpy, and I think that's it for that lesson. So we'll pick it up next time with the next concept, which is looking at the standard heat of formation. Okay, so let me know how it goes, and good luck. We'll talk to you next time.